All right, we have a bonus example in this lesson, and maybe I need to rearrange these notes because this honestly belongs more in lesson 5 than it does in this one. Before, when we had TI-84s, we didn't know how to put a log with any other base other than using the common log and the natural log. And then once we got to this change of base formula, either using the change of base or knowing how to put it into our TI-84, then we could start graphing other logs with other bases other than 10 and E, your common log and your natural log. So that's why it's originally placed in here, because now we know how to put other logs, but because we're using DESMOS more than likely, it really doesn't make sense to put it here. It really needs to be in lesson 5. But anyways, one more time, your subscript shortcut, and maybe I even need to include in here your DESMOS subscript shortcut is shift plus that minus key. Okay, so for the function f of x, we need to determine what is the horizontal and vertical shift. We need to graph it and then state the domain and range. For my on-campus students, this is what your test question is going to look like. I already explained to you in lesson 3 that you're going to have an exponential graph question where you are allowed to use DESMOS, and you're also going to have a log that you have to graph where you are using DESMOS. You're going to have 2 DESMOS questions. Once you graph your exponential and your log using DESMOS, you'll put your computer away and you'll get the rest of your test. So you do need to know how to put this into DESMOS. Okay. So what is the horizontal and or vertical shift? So this +5 inside is left or right and it's opposite. So this will be left 5. And then the -3 is up or down, and minus does mean down. When it is outside, it is predictable. Now, because you're going to have DESMOS, you can use this to your advantage. If we type this in here, okay, so just type in LOG and then use your shift minus, and you can see my cursor right there. It's now going to go down. So base 2, I'm going to arrow over to get out of there and then type the rest of it as it looks. So there is my function. I'm going to put this away so this graph gets bigger here, but I'm just typing that in. And so here is my log. Now, one thing you can kind of do to help yourself, if it wasn't shifted up, down, left, or right, the parent graph would be just simply log base 2. And so you can see, how did it go from the blue to the red? Well, it did go to the left and it did go down. So you can kind of use DESMOS to help. Where did it start and where did it end up? Okay, so now we need to graph this, and to graph this, we need some points. And on your test, it's going to say you must include 3 points, or it might say 4 or 5. So read however many points I want. However many points I ask for, it has at least those amount. So we've only really done this with exponentials. Once we type our function in the first line, we're going to go down to the second one. Wondering why that looks so much bigger. Okay, we're going to stay right there. So we'll go to the table, or we'll go to add an item and go to table. And I'm not going to help you guys with this on the test. Okay. We're gonna leave x1 the way it is. I then want to change my y1. And I'm going to replace y1 with what my function equals, with what y equals, because this is f of x, which is the same as y equals. So I'm going to copy this and then paste it here. And you're going to get this caution key. We have too many variables, try defining x. Notice I have x1 here and I have x here. Make your variables match. So I'm going to put in a little 1. And notice I don't have to do the shift minus, right? my cursor's to the right. If I just hit a 1, it automatically goes down. Okay, let me go ahead and make this big now. Okay, we've got to figure out where we want this table to start. So look at your graph. You have nothing here at -6. We might have something at -5. And so this -6, -5 would be a good spot. If you want to start all the way at -10, you can start all the way at -10. But you want to kind of see where is this graph kind of starting. And so you can see here that that X value is getting really close to that -5. So if I wanted to start with -6, -5, and it's going to kind of guess what we have from there. Now my graph here that has been provided goes from X equals -10 to 10. So I'm going to go all the way to 10. I went actually one extra, which is cool. When I kind of have these, because these are logs, we're going to get a lot of decimals. If you want to plot 0.58, go ahead. But I like to only plot these whole numbers. So what I do is I get rid of all of these ones that are decimals. And now I am just left with these whole numbers to plot. So those are the values that I'm going to plot right there. And I'm not starting with these undefined. So if I make my table, we would have -4, -3, -3, -2, -1, -1, 3, 0, and I'm going to go ahead and include 11. Now, one thing I'm also going to ask you for that it does not ask for here, but I'm going to ask, where is that asymptote at? And so you can see here, we do have a vertical asymptote, and where is it? What is it approaching? And you can see, but if you go down enough, you can see at -5, that's where it's undefined, which is what I'm told right here in this table. So we do have a vertical asymptote at X equals -5. So I'm going to put in a dashed line, and this is part of the graph at X equals -5, and go ahead and label that. And then plot your points. We've got -4, -3. I'm not going to read it all off. That always sounds annoying, but plot your points. And then pause the video if you need some more time, but connect your points and don't go over that asymptote there. Okay. State the domain and range. The domain, as we go from left to right, is vertical asymptote at -5, and it's going to keep going forever to infinity. And then what is the range? As you go from the bottom to the top, we hit this arrow first, this arrow second. All logs have a range of -infinity to infinity. Okay, so when you're asked to graph, you will be asked what is the horizontal and vertical or vertical shifts. You can use DESMOS to help you. You need to be able to find a table and get your table of values. Look at the graph again. When I look at this one, I can see it's approaching that -5, but there might be -6. That's why I started here. And then I just got rid of all of those decimals, but you need to be able to find this table of values, identify your asymptote, plot your points, don't cross that asymptote, label the asymptote, dotted line, and be able to state the domain and the range.